Hello, anatomy students. We're ready now to finish our topic on the immune system and therefore finish our discussion on the lymphatic system. I want to remind you again, in order for your body to fight off against disease and other infections, it has to put out what are known as antibodies. And antibodies are proteins that are specific against a particular group of bacteria or other infections. I want to look at 5 common antibodies, and so I want to let you guys know the IG here stands for immunoglobulin, and so you don't have to know that, but there are 5 common antibodies, and so we're going to use letters to designate them. We have IgA, we have IgD, IgE, IgG, and IgM. And so again, remember the IG stands for immunoglobulin, but you don't have to worry about that. All right, let's start with IgA, and I'm not talking about the grocery store. That's not what that is. All right, we find this particular antibody in mucus, in saliva, in tears, in breast milk, and it helps protect against pathogens. Notice that the characteristic shape of an antibody looks like the capital letter Y. Notice that we have back-to-back Ys, and so IgA as an antibody is called a dimer, spelled D-I-M-E-R, because notice there are 2 units. So remember, the prefix di refers to 2. So IgA is also a dimer because it has 2 units. All right, IgD, it's part of the B cell receptor, and it activates both basophils and mast cells. And so we have our characteristic Y-shaped antibody. We have the heavy chains here, the light chains on the top, and so these are what's going to bind to the antigens in order for the macrophages and other lymphocytes to come and attack the foreign invaders. All right, we also have IgE. Anybody here who has allergies, and I can go ahead and include myself in this, your body is making too much IgE. And so the reason that you have sneezing fits and you have stuffy head and things like that, your body is responding to things that are not necessarily needing to be attention with. So it is what is causing you to have your allergic reactions. We'll talk about allergies here in just a second. IgG is very important specifically as you start life, because this is going to be able to cross the placenta into the developing fetus. And so as a fetus, your first line of defense comes from your mother. And so your mother's antibodies in the form of IgG are able to pass through the placenta in order to give the babies their beginning immunities. And so the last type of antibody, which is IgM, these attach to the surface of a B cell or secreted in the blood, and they're responsible for early stages of immunity. And so both of these are kind of tied in together. Notice that IgM consists of not only 1 or 2 antibodies, but is 5. And so if you remember, the prefix penta refers to 5. So IgM has a pentagonal shape about it. And so again, these are all the major types of antibodies and their functions they serve in the body. I now want to talk a little bit about the 2 types of immune responses. The first that happens is called the primary immune response, and the one that happens after that is, as you'd expect, is a secondary immune response. And so if anybody here has had poison ivy, you will have a very good idea about what this means, because typically what happens when you are first exposed to poison ivy, there's no sort of allergic reaction. However, when you're exposed to the poison ivy again, then that's when you get all the rashes and the itchy bumps and stuff like that. And so this curve here represents time on the bottom in weeks, and then the vertical part here is the relative amount of specific antibody in the blood given in terms of an arbitrary unit. And so notice that Once you're exposed to an antigen, we do see a bump in the amount of specific antibody. This is our primary immune response. We do have an interval of time. It could be weeks, it could be months, it could even be years. Then, when you're exposed again to an antigen, notice that if you had antigen A already in your system, you're going to see a much higher immune response. This is our secondary immune response. If you have a second or a first exposure to antigen B, notice you have the same effect as you did before. And so notice that the secondary immune response is much bigger than it is for the primary immune response. And so I'm going to talk about each of these separately next. The primary immune response, so this little bump right here on the curve, plasma cells will release IgM followed by IgG into the lymph. So again, the whole reason we're talking about this is because the lymphatic system screens your blood and your lymph fluid in order to detect if there's any bad foreign invaders that should not be there. These antibodies will then destroy antigen-bearing agents, and the production of this can continue on for several weeks. As we can see here, this one, it looks like it's gone on for about 5 weeks. All right. The secondary antigen response, this part right here, the much larger curve, some of the B cells produced during the primary response remain dormant as memory cells, which can rapidly respond to that particular antigen. And so in the winter, when you get the flu shot, for example, which I'm hoping you are, there will be memory cells left behind so that if you happen to get the flu later on, your body will recognize it quickly and be able to mount an immune response. The memory B cells, along with the memory T cells, will produce a secondary immune response. If the identical antigen is encountered later in life, a secondary immune response may produce the same antibody within a day or two. So instead of taking weeks or possibly months to have an immune response, because of this idea of the memory B and memory T cells, now your body can produce antibodies within a day or possibly two. So this is obviously going to allow for a much faster immunological response. I want to talk a little bit about how we can classify immunity. And so immunity, we can break into both natural immunity and artificial immunity. Natural immunity, passively, again, remember the IgG antibody can pass through the placenta from the mother. This is then countered by the active, which are the live pathogens within your body. Artificial immunity can be caused both by a passive, which is an immunoglobulin or antitoxin, or can be done by a vaccination. And so I do want to let you guys know a little bit about the story behind the word vaccine. Vaccine comes from the Latin word vacca, which means cow. And so you might be wondering, why is that a thing? All right, there are two different diseases at one time. There was smallpox and there was cowpox. Smallpox was a very deadly disease that wiped out a large amount of people. Cowpox, which was related, made people sick, but they got over it quickly. And in fact, it was found that milkmaids of the ones that they mentioned in the 12 Days of Christmas, those milkmaids, they would get cowpox, but then they would not develop the symptoms for smallpox. So there was a scientist by the name of Jenner, not Bruce, no, not that guy. This was a different Jenner. He took some of the scabs from the milkmaids that had the cowpox and transferred it to healthy people. The people would develop the cowpox symptoms, but then they would get over it very quickly, and therefore they would not then be susceptible to getting the much more deadly smallpox. And so vacca, meaning cow, is what gives us our word for vaccine. And so there is the reason why that is known also as a vaccination. We have, as we talk about allergic reactions, when I was younger, I was allergic to grass and to ketchup and to dust and to pollen and lots of other stuff, which I'm still allergic to dust and pollen. And so my body would respond by breaking out into hives. And so people thought I had chicken pox. I already did have chicken pox, but these were different. The hives was an allergic response to those particular allergens. And so an allergic reaction is an immune response to a non-harmful substance. And so the allergic reactions are similar to immune responses because they sensitize lymphocytes and produce antibodies. There are delayed reaction allergies, and so you can have repeated exposure to the skin and certain chemicals, which can cause inflammation, like hives, and eruptions. And so we can see on this individual that she has had some obviously bad eruptions. And immediate reaction allergies, which can occur within minutes after contact within an allergen. All right. I finally want to talk lastly about organ transplantation and tissue rejection. In the event of a war, or if a person has had an issue with a particular organ, you can, for example, transplant a kidney from one person into another. We've had heart transplants, we've had liver transplants. One person can receive from another person a non-functional, it can be used to replace a non-functional, damaged, or lost body part. But remember, this is going to be an organ that's outside of the natural person's body. And so the body is going to see that as a foreign invader and launch an immune response. And so what has to happen sometimes, and oftentimes happens, during an organ transplant, the patient that receives the organ does have to receive also immunosuppressive drugs. So it will keep the immune system at bay so that the organs can be accepted by the individual who's receiving it. All right. I also now want to turn a little bit toward what happens when you have something go wrong with your immune system. And so some of you have probably, and I'm guessing most of you have probably heard of AIDS. AIDS stands for Acquired Immunodeficiency Syndrome, and it's caused by the HIV virus. And so the human immunodeficient virus, HIV. In people who have AIDS or have the HIV virus, the immune system can turn on itself, and therefore it can no longer do recognition between self and non-self. And so this is obviously a very, very bad situation. And in fact, most people who have AIDS don't actually die from AIDS, but they die from other common diseases. What happens in the case of this, we have autoantibodies and cytotoxic T cells will attack and damage certain tissues and other organs. The specific nature of an autoimmune disease will reflect the cell types that are targeted. And so I'm not going to go through all of these, but a lot of the conditions that you might have heard of, such as leukemia or celiac or asthma, Graves' disease, a lot of these diseases are related to a problem with your immune system. And so that is why we always have to be on the watch out for that. And so with that, we are now done discussing immunity, and we are also now finished with the lymphatic system. And so over the next a few days, you'll watch a couple crash course videos that will help go over what we've talked about, and then we'll prepare then for the Module 13 quiz. And so with that, I hope that you all stay healthy, make sure your immune systems are working well, and I will talk with you guys again